All right, on this quiz, being in class, participation was worth 5 points, and performing, demonstrating that you have learned, you could get 5 points on problem 1 or even more, 5 points on problem 2 or even more. And I set the points possible on the quiz as 10. And what this means is that you can get extra credit on this quiz, and some of the students did. Good job. The quiz is to see how well students have learned the momentum equation. Can students sketch a force diagram and momentum diagram? Can students write the scalar equations off these diagrams? Problem 1A, show how to apply the momentum equation to develop the reduced equations. Part B, explain the physics of the momentum equation for this specific problem. Quality describes what good engineers do. It's the easy way to solve problems. The number one thing to do on a momentum equation problem is to sketch a force diagram and a momentum diagram. So I'm looking for something right like this on the documentation. From the force diagram and the momentum diagram, one can directly write the reduced equation. And so you see the reduced equation right here, and I'm looking for something just like that on your documentation. It's very useful to define your positive direction. In this case, I define the positive direction as downward. So again, quality is what good engineers do or how to solve problems in easy ways. For the momentum equation, we look for sketching the force diagram and the momentum diagram, and then from the pictures you just write the reduced equation. And it's also useful to write the general equation, but I don't always do that because all the stuff you need is really right there. So I put this in parentheses. So the easy way to solve problems, or what good engineers do, is anytime you're working with a seminal equation or main equation, is we develop the ability to explain and understand ideas independent of the math. So everything we do in engineering should be super simple. One way to explain the physics in the context of this problem is the forces acting on the rocket, i.e. the matter inside the control volume, are exactly balanced by the rate of momentum flow out of the control volume. And this is what the equation tells us. In quiz problem 2, a force diagram and a momentum diagram are given, and the goal is to write the scalar equations for the momentum equation in the x direction horizontally and in the y direction or vertically. And the key idea, it's very simple. If you have the force diagram and the momentum diagram, you can easily write the scalar equations. So this is a very simple problem. In the x direction, you take this force and balance it with this vector times the cosine of the angle to get this equation. In the y direction, we add this vector and this vector upward. We subtract this vector because it's downward. Then we balance that or set it equal to the y component of this vector, so m dot v2 sine theta. And the inlet momentum flow is subtracted, so we have minus m dot v1. And the final result is right here. On your quiz, I've indicated your level of performance. Level 0, level 1, level 2, level 5, etc. And what this number tells you is how well are you learning fluid mechanics. The reason why I'm telling you about your level of performance is so that you can improve. In very simple terms, if you were going to swimming school, you'd want to be able to swim by the time you got done with school. And in the same way, I want you to know how well are you learning fluid mechanics and learning engineering. The way to think about this is that you are paying a boatload of money to be here. And to really get your money's worth, you want to be able to be learning at a very high level. So I'm giving you your level so you know if you're getting your money's worth out of your education. Okay, and all students in all classes can excel or learn the material very well. And what the researchers tell us is that it's simply a matter of choosing to do wise or smart things with your time. And so the purpose of these quizzes is to give you feedback and also show you some of the wise things, show you the engineering way. Most important thing is simply finding, why am I in school? What do I want to get out of this for myself? Everything you need to know in engineering school is in the textbooks. And so it's really a matter of finding good books and good people and figuring out what's in these books. So I have you do the quizzes. I give you feedback, and if you then reflect and grow and do this over and over, you'll get insanely good. This is learning from experience, and this is what researchers tell us is how the brain learns. So if you really want to be learning, take a minute and get out a pencil and write down 5 super useful things that you learned from this experience, i.e. this quiz and the feedback. Hope you've enjoyed this video. We'll see you next time.